Question number 4 says the top of a cliff is 40 meters above the level of the sea. A man in a boat close to the bottom of the cliff is in difficulty and fires a distress signal vertically upwards from the sea level. Find the speed of the projection of the signal given that it reaches a height of 5 meters above the top of the cliff. So this is the data. Cliff is already 40 meters and a man fires a signal which reaches 5 meters above, so this is 45 meters. And we know that velocity at the highest point would be 0. Velocity at the initial point is unknown, displacement is there, so we can use the equation v square minus u square is equals to 2as, where final velocity is 0, initial velocity is unknown to be found, acceleration is minus 10, it is going against the action of gravity, and displacement is 45. So u square is equals to 2 into 10 into 45 and we get negative 900. Square root both sides, u is equals to 30 meters per second. Second part of the question says the length of the time for which the signal is above the level of the top of the cliff. So all of this time, length of time, we're going to find this, and we know that at this point displacement is 40 meters. Either it is going up or when it is coming down displacement is still 40 meters. So the data which we can use is displacement, and we need to find the time. The displacement is equals to ut plus half at square. Displacement is 40 and initial speed we just found out is 30. Time is unknown, acceleration is minus 10, time again is unknown. So we can find two of these times. Simplifying the equation, 40 is equals to 30t minus 5t square, rearranging 5t square minus 30t plus 40 is equals to 0, dividing the whole equation by 5t square minus 6t plus 8 is equals to 0 and we can use 4 and 2. T square minus 4t minus 2t plus t is equals to 0, taking out common, t minus 4 minus 2, t minus 4, and t minus 2 into t minus 4 is equals to 0. So first is t is equal to 2 seconds and second is t is equal to 4 seconds. And we know that t would be 2 when it is moving up and t would be 4 when it is coming down. So what is the answer? The length of time for which the signal is above. So from time 2 to 4, change in time is 2 seconds. So it is above the height of cliff for 2 seconds. Third part says the man fires another distress signal vertically upwards from sea level. The signal is above the level of the cliff for 0 square root 17 seconds. Find the speed of projection of the new signal. So this is the story. This is 40 meters and the signal fired goes up, comes back, and whatever time is this t1 and whatever is this t2, t2 minus t1 is equals to square root 17. So if I use the concept, and the signal moves vertically up, reaches its maximum height and then starts to fall down. And if we consider it in two parts, let me just enlarge this one. It is moving up and then it is coming down. So it takes square root 17 seconds. So half of the time going up and half of the time moving down. So I know this time, and I know that speed at this point is 0 meters per second. So I know the speed, I know the gravity, so I can find the displacement. That is the height above the cliff. So S is equals to ut plus half at square. If I use this, displacement is unknown, initial velocity is 0, we know the time, square root 17 by 2 plus half. I'm taking acceleration positive 10 considering it is coming down and speeding up, and again square root 17 by 2, half of the time which it takes to come down. S is equals to 0 plus 5 into square root 17 is 17 by 4. S is equals to, using calculator, 5 into 17 by 4, I'm getting 21.25. So basically distance traveled above the height is 21.25. Total distance would be sum of these two. Now if we reconsider, this is 40 and 21.25, making it a total of 61.25 meters. Now I can find the initial speed. V square minus u square is equals to 2as. Final velocity at the top is 0. Initial velocity is unknown. Acceleration is minus 10. Total displacement is 61.25. So minus u squared is equals to 2 into 10 into 61.25 is minus 1225. U is equals to square root of the answer is 35 meters per second.